The purpose of the activity that we're going to do today is to find the velocity of a motorized toy car. This is the toy car that I'm talking about. Flip on the switch, and it ends up driving at a constant velocity. You're going to find the velocity of that or another identical to that toy car. Now, you guys remember from doing activities in the past, labs in the past in Science 10 and Science 9, that we always phrase a problem in the form of a question. Good news is, I'm giving you the problem here. You're going to have to write the problem when you complete this lab write-up, but you can write it exactly as I'm giving it to you right here. If you change the wording of it, that's fine. Just remember to always phrase it in the form of a question. Now, what's this activity going to look like? The apparatus, which is what you see on the left-hand side here, is rather simple, although it's going to be something that you've never seen before. First of all, we're going to have our toy car. Our toy car, which is what we're trying to find the velocity of. Second of all, you're going to have what's called a motion sensor. That motion sensor is designed to send out tiny little sound waves that reflect off of the toy car, come back and get detected, and then because of the frequency at which it's sending out those sound waves and knowing how fast they travel, we're able to, or at least the computer is able to calculate how the position of the car at various times. And then from the position of the car at various times, we're able to determine the velocity of the toy car. Now, that motion sensor isn't able to function on its own, however. It has to be connected to something that we call an air link. The air link is what we actually use as the interface to send the data, to collect the data and send the data to our phone. So you're going to have your iPhone or your Android device or whatever, your phone with the Sparkvue app that I asked you to download a few minutes ago, which is actually going to be the interface that collects that data. Does that make sense? So effectively, what the procedure is going to look like is it going to be set up like you see right here in the picture, which, by the way, when you're listing materials or apparatus for an activity, you need to list the words like I have. The photo that I have here is optional, but it's never a bad idea to do something like this. Honestly, when I'm showing you something like this and I'm trying to remember the list of all the materials, the reason that I take a photo of it and put it in my presentation is twofold. One, helps you, I think, to understand a little bit better if you can physically see it. But two, if I've taken a photo of it, I don't forget something. Right? I don't forget to mention something. Okay, if you take a photo of it and put it in your lab write-up, it's not necessary to do that. But if you do that, you are less likely to forget one of the materials and less likely to lose a mark as a result of that. All right, so when we see that photo up there with the materials there, it almost describes the procedure as well. But there are a couple of other little things that we have to do to kind of set it up. In essence, what we're going to do is turn this cart on. You can see there's a piece of cardboard on this cart. That's to make the cart bigger for the motion sensor, so the motion sensor can see the cart a little bit better, okay? So we want that cardboard on the cart. Once we have that on there, we turn on the car, and then we put it down in front of the motion sensor that's aimed at the car in the card, and then we let it go, and we measure the position and time, and it's as simple as that. More or less, as simple as that. But in order to actually collect data with the motion sensor in the AirLink apparatus in your phone, you actually need to pair via Bluetooth the AirLink and your phone. Okay, that's not hard. Okay, all you do for that is essentially what you do if you were pairing some headphones or if you were pairing your car to it or whatever. You turn on your Bluetooth. You wait until this particular AirLink apparatus appears. You're going to see it listed as AirLink and then a number, an ID number that appears on the back of each device. So you wait until it appears under all your Bluetooth apparatuses, click on that one, wait till it's paired, and then go into the app, the Sparkvue app that I asked you to download a few minutes ago. And once you're into the Sparkvue app, well, I'll show you the screen for the Sparkvue app in just a second, what you're going to do with that. One little thing before I do flip the page though, if you look at the motion sensor blown up or bigger over here, there's a little switch on the top of the motion sensor. That switch can be in two places. I don't know if you can see this or not, but there's a little picture of a person right there, and there's a little picture of a cart right there. You want the switch to be over top of the cart, okay, not over top of the person. Make sense? What that does is allows it to measure things that are nearby, like a cart that's nearby, as opposed to a person that's across the room. It just kind of determines how big the little sonic wave is that goes out there. All right. So you've got the AirLink paired with your phone. Everything's ready to go. You're ready to collect data. You're ready to turn on the toy car and measure the position and time of the toy car. When you click on the Sparkvue app, you should see a screen that looks like this. If you don't see position, velocity, acceleration, then what's happened is that you're not paired properly. Okay, you will see onboard microphone, camera, acceleration sensor. That's going to be there no matter what. If you're not paired properly via Bluetooth, you will not see this. If you are paired properly, then you will see this. Position, velocity, acceleration, and then this ping echo time. What you want to do is select position. Does that make sense? When you're in the app, select position. When you select position, that's going to take you to a screen that looks like this. It's going to be a blank graph, a blank position versus time graph. There's no data on this blank position versus time graph yet. When I'm ready to start collecting the data, in other words, when I've turned this motorized cart on and I'm ready to place it down in front of the motion sensor, I click on this little green button in the bottom left-hand corner. That's going to allow this device to start collecting the data. So I click on this, I put the cart down, and then for a few seconds, 3-4 seconds, I measure the position and time of the toy car. Now, after a few seconds, you might see a graph that looks like this. When you've got enough data, this button, by the way, while it's collecting data, actually appears red. When you've got enough data, then press that button to stop collecting data, and it'll turn green again, just like this. Now, what does this graph show us? Well, right here, as a position time graph, this graph shows us what? It looks like a pretty straight line, right? Sloping upwards means it's constant velocity, right? Over here, it shows us, who knows what the heck this shows us. That data was probably collected as I turned the motion sensor on by pressing the little green button to activate it, and as I was putting the cart down in front of the motion sensor, right? It wasn't collecting constant velocity data right away because I physically put the cart down in front of the motion sensor as it was collecting data. What you're going to do later on is just delete this data. Now over here, what's happened? Well, probably I let it go too far. So as the cart went across the room, probably the motion sensor lost track of the cart. The motion sensor couldn't find the cart anymore. So the data was pretty inconsistent over there. What should you do with that? Delete that data. You don't need to worry about deleting it right now, but later on, as we go to do our analysis, we're going to delete that data. All right? Okay. So basically, I'm saying for this, take note when you see this graph on your phone, take note, looks like we have good data between, let's say, between 4 and 8 seconds. We've got other good data as well. Right? It goes a little bit further than that, but 4 seconds of data is plenty. So remember those numbers. When you go to do your analysis, you're going to delete data before 4 seconds, and you're going to delete your data after 8 seconds. So that this is going to end up being the data that you plot on a spreadsheet. Does that make sense? So now you've got to actually export the data into your Google Drive, which all of you have, although probably only one person is going to export it into the Google Drive and then maybe share it with everybody else in the group so that you can perform your analysis. How are you going to do that? So here's our data again. In order to export the data, we're going to click on this button in the top right-hand corner. That's the share button. When you click on that, it's going to take you to a page that looks like this. You're going to export the data. Don't share the current page. Don't save it. Export the data. Now you're going to be given a few options to export the data, including sending it as a message, sending it as an email. Okay, I'm telling you, you should upload it to your Google Drive. And then it's going to be in a nice, handy place. In the end, that's where you're going to be performing your analysis anyways, is within Google Classroom and your Google Drive. So it might as well be in the same place. So click on Google Drive. When you do that, you may have to log in. Okay, I'm logged in here already when I took this screenshot. You may have to log into your Google Drive, which is just your regular school account. Okay? Once you're logged in, click on My Drive. Click on the folder that you want to put it in. Okay? Just select a folder or even create a folder if you want to create a new folder. Just somewhere where you'll be able to find the data. And then once you've got it in that folder, click Save Here. Now your data is going to be in that folder. Okay? Well, click Upload once you've done that. And then it's going to be in that folder. Then you're going to have to do some work with Google Sheets in order to do the analysis in the graph. And I'll mention that after you've collected your data. Okay, right now, we'll just leave it at this. Okay, right now, we'll just leave it at the collection of data and the transfer of that data to Google Drive. And then once you guys have all got your data, we'll work through that together in terms of bringing it into Google Sheets and how to plot a graph and so on. You guys ever done that before? You guys ever plotted a graph on a spreadsheet? Science 10? Yeah, how many people have not done that in Science 10? Okay, it's not a huge deal. Okay, we'll walk you through it. Even if most of you have already done it, we'll still walk everybody through it anyways. They have made some changes to the software this year, so it is a little bit different than it was last year, but it's still intuitively more or less the same. If you're comfortable with it last year, it's just a couple little tweaks to it this year. Okay, so what are you going to have to hand in for this? Your problem, which is phrased in the form of a question, but that's easy because I already gave it to you. And you can refer back to this podcast later on, or you can refer back to the document that I've posted on Google Classroom later on to see what the problem is. You don't have to have it memorized word for word right now. You also need the list of apparatus/materials, which I've given to you in this podcast and in the document that I posted to Google Classroom earlier on. You also need your data. I haven't shown you how to bring the data into Google Sheets yet. I'll show you that once everybody's completed their activity, and we'll work through that together. But once you've got your data in Google Sheets, then I'm suggesting you literally just copy and paste it into your Google Doc. You also need your analysis. Your analysis includes your graph, your position time graph, as well as the calculation of velocity. And then your conclusion usually relates to a hypothesis, as you guys know, but your hypothesis always relates to a problem. We don't have a hypothesis for this because we're trying to determine a velocity. A hypothesis for this would be pretty much a guess, which doesn't really serve much purpose. So we're not going to do a hypothesis. Therefore, your conclusion is simply going to relate back to your problem. The problem was, what's the velocity of the toy car? Your conclusion is the velocity of the toy car is 5 meters per second, 3 meters per second, whatever. And then how do you know? This is known because the slope of a position time graph is this value. That make sense? All right. What else do you usually have for a lab hand, and besides hypothesis, which I told you don't have to do? What else do you usually have that you don't see written here? Yep. Variables. I'm not making you do variables this time, okay? What else besides hypothesis and variables that you usually have that we don't see here? There's one big one that's missing here. Observations is data. Okay, if you call that observations, I would take that as well. Procedure. Okay, procedure is conspicuously absent from this. I'm not going to ask you to write out the procedure for this. And there's one more thing that we're missing here that we usually have. Title, you should probably have a title, but you're going to find actually when you go on Google Classroom, I've already created the document for you. So there's already a title in the document already. You're just going to click on that document and just add your stuff to it. So evaluation or sources of error. You guys remember doing that? That's missing as well. And the reason that I've left out those things is because I don't want to overwhelm you in this. Like there's enough to learn with this lab already. Okay? Using this this Sparkvue app using this AirLink apparatus and collecting data electronically, which I'm pretty sure that none of you have ever done before. Um, there's a lot of new stuff for you here. Hey, we'll do lots of activities where you have to write a procedure and sources of error and so on and so on and so on. This one, I don't want to give you too much stuff to do while we're focusing on learning how to use the technology. And so we'll worry about that down the road.